Hey everybody, I realized that we hadn't gone over this and I promised a video and now I'm finally making good on that statement. So, we're gonna go over example 2.4.8 and 2.4.9 right now. Given the following information about f and g and h, answer the following questions. So we're given just the graphs of g, the graph of f, it's kind of listen there, blurry, and then we're just given a little bit of information about h. We're just given that when x is equal to -3, h of x is 7. When x is equal to -3, h prime of x is 5. And when x is equal to 1, same thing. So the question asks us to find the derivative of f composed of g, f of h of x, evaluated at x equals 1. Now we're not given the formula for f or h. So we're going to have to apply purely the definition. So by definition, by the chain rule, because this is a function within a function, it would be f prime of h of 1 times h prime of 1, because we're evaluating the derivative at 1. Normally, like if we're just looking at the derivative at any other place, it would just, or at any arbitrary x value, it would be f prime of h of x times h prime of x. But we're plugging it in specifically at 1. So we have h of 1 is -1. And so that equals -1. And then we also have that h prime of -1 is equal to 3. Or h prime of 1, not -1, excuse me. So this is f prime of -1 times 3. But what's f prime of 1? We're not given the function, but we are given its graph. We're given its graph, and I'm going to underline this. And at -1, you might be tempted to say that f prime of -1 is 0, but that is f of -1. F of -1 is 0, but f prime of -1 is the slope of the tangent line there. And if I were to draw a line through that value, that has a slope of, let's see here, down 1 over 1, so it's a slope of -1. M tan equals -1, so that means that f prime of -1 equals -1. In fact, heck, f prime of -1.5 is also -1 because it's always going to give you the slope of this tangent line. So that's equal to -1, and that gives us a final answer of -3. Next, we'll go on to this one. K of x is equal to g of sine of x. Find k prime of pi, and then find the tangent line to k at pi. Okay, well, it's different. It's definitely a different problem. We've never seen it before, but that's not a reason to be scared. We just need to think about what we have to do. We have to find a line tangent. What do we need for a tangent line? We need a slope and we need a point. We're given neither. Or like to get any line, you need two points, which we don't have either, or we need a point and a slope. We don't have a point, but we do have an x value, which means we can get a point. So we could find that first, or we could find the slope first. I'm going to find the slope first, and the slope will come from the derivative. So we need k prime of pi. That's going to be the slope of the tangent line. So that's what we need. But k prime, we'll get that later. Actually, I'm going to delete it for now. K prime of x, by the chain rule, would be g prime of sine of x times cosine of x, because it's the derivative of the outside function being g, and the inside function being sine. So that is the derivative of k. Whatever that may be is irrelevant. We can still plug in values into it. So k prime of pi, well, that's going to be g prime of sine of pi. And I know we're all at times cosine of pi. And I know we all love our trig. Sine of pi is 0. Cosine of pi is -1. So this is equal to negative g prime of 0. And by a similar argument as before, looking up above, I'm going to underline this one in, let's use pink. Why not pink? G prime of 0. So the graph of g is given in blue. And if I were to try and find a g prime, that would be the tangent line slope at 0. So there's g of 0. G of 0 is 1, but g prime of 0 is the slope of this tangent line. M tan equals 0. So that means that g prime of 0 equals 0. So k prime of pi is equal to negative 0, which is just 0. So let's just write 0. And that, in fact, is the slope of our tangent line. Yes, it is possible for your tangent lines to have a slope of 0. It's totally fine to have that happen. It doesn't happen very often, but still. And so now we need the point. And the point would be coming from k of pi. Because remember, we're finding the tangent line to k, not to g or anything like that. We're finding it for k at pi. Well, k evaluated at pi would just be g of sine of pi. So that's g of 0. And we just talked about it above. What colors have I used? I haven't used red. Ooh, well, red's going to look bad with pink at the same time. So let's use blue. We haven't used blue. Cool. So blue, g of 0 would be the y value on the function g. We're given the graph of g, so g of 0 would be 1. So that equals 1. And so we have a point, pi, comma, 1. That's the point we have. So we have a point, we have a slope, we have everything we need. Y minus y sub 1, so y minus 1 is equal to m, which is 0 times x minus pi. And this is the one time where I'll accept converting it immediately to point slope or slope-intercept form. So or y equals 1. Either one is acceptable because when you multiply by the 0, everything goes away. Either one of these is a good option. And that is example 2.4.8, excuse me. 2.4.9 is very similar, but slightly different. Instead of being given graphs, we're just given a bunch of information about two differentiable functions, f and g. We're given that f of 1 is 7, f of negative 3 is 1, g of 1 is negative 5, g of negative 3 is 2, and we're given information about the derivative at those x values as well. It says define k to be this, which by the way, as a reminder, that is g of f of x. That's what composition means. And so we're going to find the equation of the tangent line to k when x is equal to negative 3. Very, very similar process. We need a point, we need a slope, and we're not given the point, we're just given the x value of the point. So we need to use the function itself to find the y value. So for the slope, that would be k prime of x, which we're not given any information about f and g, so we just have to appeal straight to the definition. That would be the derivative of the outside function, so g prime of f of x times the derivative of the inside, f prime of x. So k prime of negative 3, which is going to be our slope of our tangent line, is g prime of f of negative 3 times f prime of negative 3. Well, we know that f of negative 3 is 1. That's equal to 1. And f prime of negative 3 is 2. So what we have now is we have 2g prime of 1. And now we'll have to look for g prime of 1, which is 5. So we have it's equal to 10. That is our slope of our tangent line, m sub tan. And we've got that. And now the only thing left to do is to find the point. And that's going to be finding k of negative 3. Not k prime, but k of negative 3, which is simply f, or sorry, not f, g of f of negative 3. Now we already found f of negative 3. That was equal to 1. So this is equal to g of 1, which that one we're going to need to, let's use green. G of 1 is given right there in the information. So this right here is equal to negative 5. So we have the point, our x value is negative 3, our y value is negative 5. We have our point, we have our slope, we have everything we need. Y minus y sub 1, so y plus 5, because it's minus negative, equals 10 times x minus negative 3, so x plus 3, Or if we really want to simplify it, y equals 10x plus 30 minus 5, so plus 25. Either way is acceptable. I'd prefer the first form because it gives me more information about the specific tangent line in question. It tells me where the tangent line's occurring and the slope right off the bat, but either way is acceptable. All right, guys, that'll do it for this video. I hope it's useful. Good luck studying, and I'll see you on Monday.